and Society, new initiatives of the EPS. Please.
Thank you very much for the introduction. So, well, we had just, a talk by the IUPAP, the Secretary General. So I will be pleased, to take the follow-up about another international learned society. So before that, I would like to thank very much Angela Bracco, for inviting me, and the Italian Physical Society. It's a real pleasure to be here. We have many, many beautiful things in Paris, but as I must say that we have nothing like this, and I never saw that in my life before, so thank you very much for the invitation. I'm going to talk about the global challenges in physics and society. That's the main theme of this meeting. And I will focus more about what my predecessors did to anticipate, the issues related to the climate change and sustainability, and what we are going to do in the present years and the coming years. Okay? Oops, that way. Just to start with, I would like, to briefly tell you what, the European Physical Society is. So we are an umbrella organization for 42 member societies, covering all the European continents here. So I don't know if yes, it works. Well, basically, we cover all the national physical societies from Portugal up to Ukraine, Belarus, and Scandinavian countries, and Greece particularly. We have two secretariat offices, one in Mulhouse. The European Physical Societies was founded in 1968 under the inspiring leadership of Gilberto Bernardini, who was director of research at CERN. And the key idea behind, this initiative was to promote physics for peace. So it was created after the invasion of the Czechoslovakia by the troops of the Warsaw Pact, and this was done in response to this war. But it was first settled in Geneva, and then for financial reasons, I think, partly, the EPS moved to Mulhouse, which is here, okay, not so far from Strasbourg. And since 2016, we opened a point of presence in Brussels. So as I told you, we are an umbrella organization for 42 member societies, DPG, IOP, SIF also, French Physical Society also. We have 12 divisions and 6 groups. So, these divisions are in charge of dealing with the different branches in physics. So that's for treating pure science. We have 40 associate members. These associate members are mainly recruited among, before they were recruited among the universities and museums and large research infrastructures, but for a few years we have put our efforts to recruit them among industrial partners, startups, companies, and so on. I will say some word about that. We have also 30 cooperating societies, like APS, the American Physical Society, for instance, with whom we have some bilateral agreements on some dedicated actions. We have 3,500 individual members, so a little bit less than the APS, for sure. But we revindicate the fact that we are of interest for 130,000 physicists in Europe. Our role is to facilitate the research in physics. So I said some words about the 12 disciplinary divisions. You know probably some of them: quantum electronics and optics, for people doing optics and photonics, physics education, plasma physics, high energy particle physics, nuclear physics, and so on. We have also 6 interdisciplinary thematic groups, like the energy group, the technology and innovation group, physics for development. Talking about the technology and innovation group, Chris Russell is the chair of this technology and innovation group. He's also the chair of this science and industry working group you have at IUPAP. So, you can find several people having some responsibilities in the past in the EPS. He was, by the way, a former president of the EPS, and continuing to promote physics and society in other learned societies. So we also organize conferences in Europe. Well, I mean, our disciplinary divisions, mainly, I mean, their main task is in organizing these conferences. They also present some, give some grants to help young researchers to attend these conferences. We distribute prizes and awards, and we have also some publication activities. And our flagship journal is EPL, who was formerly, I mean, the Europhysics Leaders Journal. Our role is to shape the European physics community. So in connection with the main theme of this conference, I mean, I will address more, I mean, the Forum Physics and Society. We had some actions in the recent past on that. And also I would like to advertise what we offer in terms of physics and the economy. I mean, usually, I mean, regularly we elaborate or we write a report about the impact of physics to the economies in Europe. And this is prepared by a private company which is installed in Brussels, and that's the Center of Economy and Business Research. And they work for us for collecting data and present a nice report to see how basic science can impact directly the economies. Of course, you have to consider the role of startups and small and middle-sized companies for that. We have some actions on education through the physics education division. For instance, we were called, I mean, to validate some online courses during the COVID periods. We have a very active committee on equal opportunities. I mean, I was the chair of it before becoming president. We present the Eminauteur distinction to noteworthy women in physics. We also developed, I mean, this nice initiative of gender fairness in order to measure women physicists who could and who can access the highest responsibilities in the EPS sponsorized conferences. We published recently a code of conduct for the EPS conferences. We also give some input in the framework programs of the European Commission. And we cooperate with the Initiative for Science in Europe, which is an impactful also association at this level. We work a lot on the European integration and how to integrate better, I mean, the national physical societies who are in the eastern and southern parts of Europe. So you can imagine that we have some work with the war in Ukraine. We try to do some lobbying for getting more research funding, in particular for these Central Eastern European countries. There is a very nice initiative which is the EPS historic sites, and we have a committee for that. So, I mean, we like regularly to recognize buildings and places where seminal work have been done in physics. And this initiative was launched in 2011 by Luisa Cifarelli, who was also a former president of the EPS. So thank you, Luisa, for this initiative. It's very successful. And we accompany, I mean, the next generation of physicists through our Young Minds Action Committee. We are also in charge of the Secretariat of the International Association for Physics Students. And I typed here management. So, well, I mean, since I took my term 1 year ago, I set up some working groups. So I believe that it was very, very original. But I mean, what I saw this morning, it is not. And in fact, the idea is that with these working groups, I mean, you can have a reduced format of meeting between different people, and you can try to work better than just having big meetings. Okay. So, Angela, you asked me, I mean, to address the challenges for basic science sustained development in relation with the activities at the EPS. By the way, I hesitated a little bit, wondering whether, I mean, I had to address the activities at the EPS or where I'm working. Sorry, I forgot to introduce myself. In my current life, I'm a physicist, and I'm working at the Commissariat for Atomic Energy and Alternative Energies in France. So if you know Saclay, this is not really the center where I work, but I mean, we are really involved in the nuclear power and what we can do with that. And I mean, during my slides, I mean, you will see that it transpires more or less well. But here I will address what we can do for the sustainable development. and what are the challenges for basic and also applied science for that, at least at the level of the EPS. So I think that an important point is to address the role of physics in the economies, and in particular in the economies of Europe. And I mean, for me, I mean, you cannot do, I mean, progress in sustainable development or mitigating the climate change if you do not put the industrial sector in the loop. So it's really important, I mean, to have also what the industry is doing with physics. And we regularly publish this, this report. There is some sound, no, behind? Or I should be here. Isn't it better if I am on this side? Yes, it's better? Good. So we published, I mean, with this report, the importance of physics to the economies of Europe. I told you, I mean, a company collects data from all the physics-based industries working as a multinational firm, or a small or middle-sized company, or startups or spin-offs working in material processing, telecommunication, high-performance computing for physics, for instance. I mean, all branches where the physical principles are used. And when you measure, I mean, the impact of these industries, I mean, between 2011 and 2016, physics-based industry typically accounts for 16% of the total turnover of the EU 28 countries working for the business economy. And this represents 4.4 trillions of revenues in Europe, and the gross value added of the physics-based sector in Europe has exceeded 1.45 trillions of euros in each year of this period, 2011 and 2016. And when you look at the figures, I mean, you see that the more we go, I mean, in the years, and the better is the growth, you see. And so, I mean, the next edition of this report is in progress. I mean, and it will cover the period between 2017 and 2023. About sustainability and climate change and so on, of course, we have two groups. I mean, one group, the energy group, and one division, the environmental physics division, working on this issue. And they were very active, let's say, I mean, 15 years ago, and then the years after, of course. And you see, I mean, they published, I mean, a couple of position papers in 2007, 2009 about the nuclear option. So, I mean, when you read, I mean, this position paper, we already announced that, I mean, we have not to drop or to abandon the nuclear option in our recipe for making a sustainable energy and for fulfilling, I mean, the challenge for reaching not clean energy, but not for emitting CO2 emissions. So, I mean, it is necessary, I mean, to consider this option. And then in 2009, another position paper was published about the intimate link between energy and environment. And I will show you a few of sentences. And more recently, I mean, we published another position paper in 2016 about how to focus on the electricity production by non-fossil sources. So typically, I mean, the first position paper we published, I mean, it was clearly said that nuclear power can and should make an important contribution to a portfolio of sources having low CO2 emissions. And then what was really interesting in this other later position paper is that here you can see many, many graphics like these, collecting all the data available at that time, alerting people on why, I mean, the problem of the global climate change was so important and how urgent it was to face it and to answer it with some dedicated answers. So here, I mean, that's one of these graphics where, I mean, I'm showing you, I mean, the global mean sea level taken from a database, which was a French-American TOPEX, Poseidon and JSON satellites, showing the growth of the sea level year after year due to the global warming. And the last position paper we had was published in 2016. In this position paper, I mean, at least for once, to the best of my knowledge, I mean, it was recommended to involve research and development companies to be in the loop in order to accompany, I mean, this change. And what was said that Europe alone cannot curb the increase in global CO2 emissions, so global action is required. This is for sure. When you know, I mean, the level of pollution from China or even US, I mean, you cannot act alone. An efficient expansion of renewable energy sources requires solutions for intermittency and storage. That's a point, how to store the energy. That's an important point. The EU energy policy should be framed to strengthen Europe's economic position in the world. That's true. I mean, I think we are showing the good example in Europe, but perhaps not enough. And we should lead, I mean, the global effort in reducing the CO2 emissions. So the recommendations were to reduce worldwide CO2 emissions, consider all non-fossil electricity options, and also educate your young generations to this question of global warming and developing some sustainable energy. We also keep an eye on the future. I mean, we talked about the thermonuclear fusion. So you know that you have two ways to reach thermonuclear fusion. The magnetic way, where you use tokamak. So we visited twice the ITER facility. And recently it was with the Technology and Innovation Group. And also we were accompanied by the Swiss Physical Society. And this was done in November 2021. So we could see, I mean, this huge magnetic coil here done with supraconductive materials. And here, I mean, you will have, I mean, the plasma, which is planned to be ready by 2025. And in 2030, they plan, I mean, to have the first gain source of electricity. The other means that the laser fusion, so what we call the inertial confinement fusion, where, I mean, you took 180 laser beams, so, I mean, they focus a large focal spot of 40 centimeter over 40 centimeter on a target. I mean, basically, I mean, you have what we call a whole home, which is made with gold, and the lasers are going to irradiate the golden whole home. That will create some X-rays, and the X-rays are uniform enough, I mean, to irradiate homogeneously a target capsule, which is containing some deuterium and tritium. And from this, I mean, you create a fusion. And in August, at the National Ignition Facility, as you have certainly heard about, I mean, they reached a breakthrough approaching, I mean, the break-even limit. So we believe that, I mean, both these ways will soon answer, I mean, or will contribute to offer alternative solutions for the production of almost clean energy, let's say, yes. About physics and society, we have a forum which is dedicated to these aspects. And regularly, perhaps not every year, but every 2 years, we initiate some actions where we gather, I mean, eminent scientists to think about what is the state of the art of their disciplines and how this discipline contributes to the society as a whole, okay? And recently, I mean, Carlos Hidalgo, maybe, I mean, some of you know him. I mean, he's very active, or he was very active inside the EPS, took the lead of organizing, I mean, the grand challenges in the Horizon 2050. The goal of this event was twofold. The first objective was to addresses the challenges in physics and the interconnections between the different fields of physics that will shape the future in the coming 30 years. So, I mean, two themes were investigated. I mean, the physics has global human enterprise to understanding nature, and the second theme is physics developments to tackle major issues affecting the lives of the citizens. So on the one side, I mean, you treat the hardcore problem of the physics what remains, to be done to advance in physics, and on the other hand, you address what will be, the impact of the progress in science for the citizens. So, and this will result, and this resulted first, so one event was organizing a meeting at the Magnus House in Berlin by the end of October 2021. This was organized with the Deutsche Physikalische Gesellschaft that celebrated its 175th birthday. And all this work will be published soon by IOPP. Has a very big book, I think 600 pages of scientific articles and also societal impact, societal articles, sorry, led by 12 editors from the different divisions and groups of the EPS, and the authors are coming from 19 different countries. Here, you have an example of the program of the Grand Challenges. The meeting that took place in Berlin. So, where there is, challenges for science of cities, or how you can employ the statistical physics to guess what will be the evolution of cities, or public transportations, for instance. What about the Higgs boson? What about the coronavirus? And you see, one person addressed both issues here, accelerators for health, and so on and so on. I would like to end my talk by telling you some of the new challenges I tried to settle when I took my office. I talked about the working group that were set up like 2 years ago. We have 3 main working groups that are active. The first one is dedicated to the link to industry. So I told you, you cannot go on doing science properly without taking some industrial partners with you. That's just impossible. For learned society, and I think the American Physical Society is also facing the same problem. How are you going to keep inside your learned society students? And the majority of students are going to find a job in the industry. So how you accompany these students and how you keep them. That's some major issues. And so we need to develop some links with the industrial people, and this is what we did. And so we set up this group. A second work group was to organize a sustainable showcase for the EPS. Unlike, the other learned societies, national or international, we had no showcase events. Or in the past, we had a general assembly, or we had a scientific congress, but this stopped during the year 2005, and the idea was to relaunch this kind of initiative. So this is why I wanted to have this forum and try to make it sustainable. So that's also a sustainable event. And the third effort will be to help researchers from developing countries to come back to their alma mater institution in order to keep a high scientific level. So we try to contribute to the International Year of Basic Science for Sustainable Development by this way, and also to reinforce the links with the Eastern states. Joe Numila, who is in the audience, is a member of this work group. Let me summarize, what we did, for reaching better the industry. First of all, we launched a survey which we distributed to 60 or 80 companies in Europe, working in power supplies or electricity or whatsoever, and asking them, okay, would you like them to join the EPS? And if you join the EPS, what would you like to have for activities, to do something all together? And we received about, 30% of responses with new initiatives that were proposed, and there was a need or request of networking better and more intensively between academia and the industry. So here, you can read, these graphics, it's too small, but we received answers from, 20 countries in Europe, and a lot from Italy. And talking about Italy, I have to thank a lot, the Italian representatives for joining us in priority, because, this surveys initiative allowed us to attract new associate members. Politecnico di Milano became our first societal sponsor, so we divided, the different levels of the associate members, like prestige sponsor, societal sponsor, prestige sponsor. A company can propose a prize, a new prize, and fund a new prize, and we organize with it, with this company, this prize. And societal sponsor give a little bit more money to fund our activities on the societal issues related to physics, of course. And you have, the basic level that supporter associate member. So in 1 year only, we got 4 new members: Politecnico di Milano, Cecom, Ocem Power Electrics, or Power Supply. All of these are Italian companies. And we got a Spanish one, working with the University Autonomous from Madrid. So we increased our portfolio of associate members by 10%. And what we are working on now is to propose a business web platform to industrial people in order to network all together and to be in touch with the large research infrastructures and to prepare all together some events. We will also offer an access to some CVs of students, also a database of job offers and so on. Okay, well, in Paris on June 2 and 3, the objective of the working group number 2 was to organize, the first forum of the European Physical Society. So it took place in, 2 weeks ago at Sorbonne University in Paris, and we had almost 500 participants on site, 184 students. This is a number that will have to be increased in the coming years if we sustain this event, and 30 countries were participating. Even Guatemala and Singapore, which is not really European cities, but European countries, but we were happy to have them. So we had some conferences, roundtables, hands-on, and poster sessions. I will not go into the details because many people from here were attended this event. The third work group, that's Physics for Development and the joint actions with the Eastern States. So you see, I forgot to mention that these names here are the names of the members of these work groups. Joe is here. We have the former president of the Polish Physical Society. We have the president of the Balkan Physical Union, and so on. We have the president of the CERN Council also. And one of our first works was to put in a good shape an initiative that was launched by my predecessor, Petra Rudolph. And in fact, we agreed on writing and drawing up a memorandum of agreement with the American Physical Society and ICTP. And the goal was to offer 3 grants to 3 candidates. So basically, it's $5,000 provided to them, and helping them, to go back to their alma mater university in order to continue to keep a high scientific level. This year we received 10 applications, and the selection committee did a great work in selecting 3 laureates coming from Cuba, Pakistan, and Iran, and they will go to UK and to France. If you want to know more, please go on the website of ICTP, and you will see all the rules. All the logistical part of this program is taken in charge by ICTP. Of course, we will be present for the International Year of Basic Science for Sustainable Development. We are part of the steering committee, and we are very glad to be part and to be here. So, and we will be present during the World Conference on Basic Science for Sustainable Development in Serbia, and also, of course, at UNESCO on July 8th. We prepared, by the way, a flyer. We started to distribute this flyer during the EPS forum, and we try to advertise this important event. We will also participate to the 11th Congress of the Balkan Physical Union in early September. We have also other actions in the directions of Africa. For instance, we support a conference organized by the Portuguese-speaking countries And this will take place in Cape Verde in September 2022. We have also some action with some local university, Université Haute-Alsace, where is located, the EPS Secretariat. And we try to help women in some villages, to have some water and so on, and to involve also the young minds for this project. And more recently, a couple of days ago, we also gave some support to some African physicists to attend a conference in optics, which is LEAP 2022. Typically, this kind of event, this association I mentioned, MCDA, would like, to organize. It was delayed due to the COVID, but typically how to use water in a clever way in order to supply to the needs of villages in Morocco. The last actions I would like to give a few words. We are revising the statutes and the bylaws of the European Physical Society. So I was elected for 2 years, but I was renewed for 1 extra year, so exceptionally in order, because we need to change also to replace, the Secretary General of the EPS, and this takes time. But also, this is a good chance, to revise the EPS constitution and try to adapt it in a more modern way. You see, I put here in boldface, basic science needs to partner with industry to sustain development. When you read, the EPS strategy plan of 2010 that was written 12 years ago, you have no mention at all of the link we should make with the research and development companies and so on. And of course, you cannot do that today. So we need to include better, the integration and the involvement commitments coming from the startups, the companies, and so on. We would like also to offer some travel grants and to support to researchers from developing countries. So this also applies to European integration. So this is what I'm trying to do with the members of the working group. We want to increase the visibility of the EPS as an umbrella organization. So we organize a forum, but we would like to make it sustainable, and then you need to revise also the EPS statutes. And for this, you need to have some members and to have a work group dedicated to this task. And we will have, the pleasure to host the Secretary General of the DPG and also Stuart Palmer, who is a member of the IOP, to think how to do that properly. And with this, I would like to thank you very much for your attention.
Thank you, Luc. Very interesting and informative. Questions or comments, please?
Thank you very much for your talk, Luc. I was curious about Working Group 3. How far east is east?
Okay, that's a very good point, because I did not address, our position with respect to the war in Ukraine. Maybe this is what you do. Okay, we go up to the Ukrainian Physical Society, the Belarus Physical Society, and the Baltic states, Finland, and Greece. I think that Turkey is a cooperating member, but we do not include Russia. Russia was a founder of the EPS at the beginning, but it's not a member society of the EPS. Because, we have not the equivalent of the National Physical Society in Russia. You have the Russian Academy of Science. Yes.
Another question here.
I was impressed by the numbers you showed for the influence of physics to industry in Europe. Just a technical question. How did you collect this data? What was the methodology? Because to come to a number like trillions or so, I assume you did a lot of estimates.
Oh, yes, for sure. And we didn't collect ourselves, the data. So,
because this, if you can give some details to people that are doing the same job,
yeah,
it will be very, very crucial
to
give paradigms to people that would like also to do this at the regional level.
Yes. So if you are interested, you can download the report directly from the EPS website. This can You have two reports. You have the nice report of 16 or 20 pages. It is easily read. And you have also other data. And this very thickness, and the data as collected and treated by the Center for Economy and Business Research, with a center working for the European Commission directly. Okay.
So thank you for the very nice talk.
Thanks.
I agree with you completely that it's important to connect basic science to industry. When you did your survey of the companies, what were the number one things that the companies wanted out of EPS?
What was the number of companies who wanted to join the EPS? This one. Why? Basically, we got among them in the 30% of companies, we got 10, 15 who wanted to join the EPS. But the main advantages of joining the EPS was to be in touch with the academic sector, to be in touch with the basic researchers, and to be able to join European proposals. You know, this ERC and all these funding programs, they want to be present too, of course, the industries. And a learned society can help to make the bridge between the two communities. This was, the first point. And also to network with the scientific community as a whole.
To make stronger the voice of the community, of course.
Of course. Yes.
Thank you, Luke, for a nice talk. I wanted to go back to the Ukrainian crisis. Because it seems to me that this is going to have, but is also going to have devastating consequences for our colleagues, the physicists in the country. Now, some of them managed to flee. Some others are still there. We're all, I guess, taking actions, individually, but also through our institutions to support our colleagues in these very difficult times. But sooner or later, hopefully sooner, there will be a time in which we will have to consider reconstructing physics in the country. So I was wondering whether the EPS is starting to think about actions that we might have to take collegially, perhaps, all together to support the community in their reconstructing the physics in their countries.
So I'm going to answer you in two steps, if you allow me. First step, the war started on February 24th, yes? Or the invasion, or the aggression, on February 24th. On February 26th, the EPS took the decision, of course, collegially with the members of the executive committee, to freeze all collaborations with the Russian institutions. Of course, the research institutions in Russia are all depending on the Russian state, so it was easy. We had 4-6 partnerships. We stopped them first. So it was very fast and very clear. And I remember that Amy Fladen phoned me, and I discussed with Amy and also with people from Optica. The reason of being so clear and so sharp was that the Ukrainian Physical Society is a member society of the European Physical Society. Okay, and we received many calls from them. Please help us. That's a catastrophe. Okay, so first we freeze. Second, we didn't give any strong recommendations how to invite or not Russian physicists during the conferences. This is, to the freedom of our divisions and groups. Third, we are going to publish a list of websites that give access to how to help Ukrainian physicists, how to help Ukrainian children, how to help Ukrainian people as well, not only physicists. And second, what we would like to do is to contact the European Commission, and they have this ERA 4 initiative, in order to start to collect some fundings in order to reconstruct the laboratories and research centers in the middle term. Unfortunately, I do not believe that this will be done tomorrow. But of course, we need to do that. We need to anticipate what will happen, fortunately, in the future. And what we hope is that the war will cease, and then we can reconstruct the labs. So you see, we have different actions.
Okay. Thank you again, Luke,
Thank you
for the very nice talk. And now I introduce you Annie Abrahamian, University of Notre Dame, United States. Will Armenia realize its potential in delivering advances in the fundamental sciences while developing an ecosystem for a high technology innovations? Please give us the answer to this question.
Thank you very much for the introduction. I would like to start by congratulating the Italian Physical Society on its 125th anniversary. It's very impressive to be here in this beautiful place in the Fermi room to discuss the challenges that we have today. I would like to thank Angela Bracco and the organizing committee for inviting me in this international symposium to discuss the global challenges that we face in fundamental sciences, our sustainability issues, our passion for science, and for Armenia, it's our survival as well. So many of you who know me, you know me as a professor of nuclear physics at the University of Notre Dame. I'm a nuclear physicist by trade. And 4 years ago, I accepted to become the director of the National Science Laboratory of Armenia. This is at the same time, so basically I doubled my workload. I don't know if in Europe you're allowed to work 100 hours a week. You're probably not, but in the US, we do crazy things like that. Okay, so the question is a difficult one, and I chose it because you will see as I present some of the issues that I don't know the answer. Unfortunately, I cannot give you an answer, but I will certainly tell you about our attempts to get there. So first, where and what is Armenia? So here we are in this beautiful place. Oh, I'm supposed to point there, I guess, with the pointer. No, here we are. Okay, in this beautiful place in Italy. And Armenia is way over on the other side of the world. The dot almost covers the entire country on the map. It's a small country. At the moment, it has a population of less than 3 million people. Armenia is a post-Soviet republic, so independent from the Soviet Union 30 years ago. And all assessments of the population is that it's a high potential for STEM sciences country. These studies have been done by the World Bank, by the US Science Academies and all that. The fact is that Armenia has the highest per capita number of physicists in the world, more than Russia. And that's kind of historical. And I'll mention how that is. So what is the National Science Laboratory of Armenia? It used to be the Yerevan Physics Institute. Many of you may know that, may recognize the name, Yerevan Physics Institute. It only became the National Science Laboratory of Armenia 10 years ago. The logo of the lab is Change the World with Science. This is very important for all the young people in Armenia who until recently could see no hope in pursuing a science career. But the government of Armenia is making a big effort to try and encourage this. First, a word about how it was founded. It was founded by two brothers, Alikhanov and Alikhanyan. They were studying cosmic rays on top of Mount Arakat in the Caucasus. It was founded during the war, 1943, and the Alikhanov brother went on to found the Kurchatov Institute in Russia. There were a number of firsts at the Yerevan Physics Institute. It was the first in the Caucasus to bring internet to the region. And 2-neutrino double beta decay was first measured at this lab in Armenia. This says 7. We go back and forth on the 7 and 6 GeV electron accelerator from the 70s at this lab. It was the Armenian scientists that immigrated to the US in the 90s and helped build the CBAF electron accelerator in the US, which was a 6 GeV electron accelerator in the 90s. Armenia during the Soviet times was a highly scientific focused country and produced the computers. It was the Silicon Valley of the Soviet Union. All of that disappeared and went away when Armenia became independent from the Soviet Union. Just a few words. So during Soviet times, there were more than 4,500 people working in this laboratory with 3,000 scientists. Today it is it's something like 10% of that. There's 350 people there. And the electron accelerator was run until the 90s, but it's no longer run, very highly electricity intensive. There is a 75 MeV injector, which is run today, and you'll see that it's a part of the Accelerator Complex for material science that is relevant for today. And there is a new 18 MeV cyclotron, proton beams, operational since 3 years ago now. So YERPI, Yerevan Physics Institute, became the National Science Laboratory of Armenia after a committee of experts. There was an international committee of experts, heavy with European representatives, that suggested in discussion of what the future of this place might be. And the chair of that committee was Yuri Oganesyan. And that was how 10 years ago, YERPI, a physics institute, became the National Science Laboratory of Armenia. This figure can be confusing. Let me just say that 30% of all the scientific publications from the country of Armenia are from this institute, and 70% of all the citations of any scientific work is from this institute. The numbers of publications have been going down because of COVID, but I just wanted to show you what the numbers are. There's 154 scientists and 107 engineers and technicians at the place right now. It continues to be a center of excellence in the region. There is no comparably well-established and known scientific institute of any kind. These numbers here, 379 publications or 304, these are in international referee journals. We're not counting the local publications. Okay, so the concept of a science laboratory was new to Armenia. So there were, on my first visit to Armenia in 1996, I discovered there were 60 physics institutes in Armenia. I could not imagine how this was possible because I don't think we have 60 physics institutes in the US. But this was just inefficient and whatever. But a national science laboratory, just trying to convince people that this is how we do it. So the sustainability and innovation has to come from the place where you have the sciences. So National Science Laboratory still have to do world-class research, because without that, the scientists would not buy into any of this. They really felt that innovation and applications of science are second-class activities for them. So this was a part that we had to grow and change. Okay, so what's the vision? The vision is that we still want to be a regional center of excellence. We want to continue all the work in high energy physics, nuclear physics, astrophysics, cosmic rays, but we want to add the applications in nuclear medicine and some of the other things that affect the economy. It's not just wanting, and I'll present some of the ideas that we've actually managed to realize. It's very important to identify the areas in which we can be globally competitive and not just do it just because that's the way it's always been done. So that's where having someone from the US with no ties to any of the projects in Armenia was helpful, I feel. Okay, so you have to start with where you have strengths, and that has been the approach. Presently, this laboratory, Ali Khanian National Science Laboratory, has 7 divisions. An experimental division that is involved in all the large experiments around the world. The cosmic ray division, which is done with observations, with high altitude observations. A theory division, which is probably our strongest area in mathematical physics, and lots of grants from ICTP in the past. Computation, applied physics. A new division was founded 10 years ago called Isotope Production and Research. And there's the Theoretical Cosmology and Astrophysics Center. So building on the strengths we have and starting new ones. The new one was this, I started a quantum technologies group in the beginning of this year. So it was very important in this transition to keep to the world-class research. I mentioned that already. And we're doing that already. Armenia is involved in all the large experiments around the world. In the US, in Europe, we have 3 groups at CERN actually, in Japan, United States, and with Gìugno, of course. I want just to show a bit that Armenia is engaged. There are over 70 MOUs in both theory and experiment with different countries. And in 2019, before COVID, we had 12 conferences, 12 international conferences in Yerevan. And this is just to show that lots of people do like to come to Yerevan for lots of conferences. Just a word about, we had to think about how Armenia's science and technology and innovation could be disruptive. I mentioned that it's a matter of survival. I think many of you may not remember, since it didn't make it in the news, that in 2020, Armenia was attacked by its neighbor, Azerbaijan, with the help of a NATO country nearby, Turkey. But that hardly didn't even make the news in the West. So we didn't realize that that was going to be the beginning of what we see happening today. In any case, the thinking is for Armenia to survive, you have to be a science and technology outstanding country. That's our only hope for peace and for prosperity. There is no other way to go for Armenia. So this quantum technologies division that I just started in the beginning of this year is initially mostly theory, but we're also developing a component in quantum sensors. We have some expertise in that. We feel that there's no country that can afford not to be a part of the game. Europe, US, China, everyone is pouring in and making quantum technologies their top priority. It's the next revolution. We must be a part of it. I'll just mention on the quantum sensors some of the international collaborations that we already have. That's within Armenia and also outside. For example, University of Glasgow, Mainz, Johannes Gutenberg University in Germany, Eli MP in Romania, and Japan. So lots of people are interested in some of these very fast RF timer systems, and we're working on lots of developing other areas. A proposal that I will later this week hope to present at ICTP is building on the strengths of the theory division. We have outstanding theoretical physicists in Armenia. That was the part that was easy to support because it doesn't require much money to do experiments. And our proposal is to join up with the American University of Armenia and develop a graduate program in physics taught in the English language that could be an attractor in the region. I think Iran, Georgia, perhaps even Azerbaijan and Turkey would participate in such a program. If it's taught in English, it would have the benefit of the incoming brain power into Armenia rather than out of Armenia. So we'll see how that goes. The proposal is just going to be presented this week. The other aspect was we built on expertise in detectors. So cosmic rays, Armenia has always built these huge detectors worldwide. They're all over the place in Europe as well. So we combined the expertise in making detectors with the accelerator experiences to register Armenia as a partner country for the electron-ion collider. It's a big DOE project that's about $2 billion. The US had started it in January 2020 and with something called CD0. Armenian scientists have participated in JLab, Jefferson Lab, and CBAF, but this is the first time that they register as a partner country. So in 2021, actually, I established a laboratory for advanced detector development. So Armenia would take parts of the detector development and do some of the testing in Armenia. And then also to make new detectors. So we have expertise in developing detectors, but making new detectors, like for medical physics. The normal PET detectors are, the PET scanners are quite expensive, big things. But if you can develop smaller ones, you can do lots of development in testing small animals or even plants. This could be a huge boon for Armenia because the agriculture in Armenia is the #1 contributor to the GDP, and it's very outdated. And also, Armenia has a pharmaceutical industry, but they have not been able to test or deliver drugs to Europe because they have not been able to prove this transference between the blood-brain barrier. And now with PET, you can do that. And if you can have smaller PET detectors, you can do it more cheaply. So these are all areas that are now made possible because the cyclotron is working and producing isotopes. These are some of the, like instead of doing a big thing like this, you could do a smaller thing and look at an animal or only a part of the body and so on. So we find this to be very promising, and we've just started work on this area. There are also lots of new materials that are coming on the market that are quite good in imaging. I mentioned the agriculture part. This will take some convincing in Armenia to do radioisotope tracing in plants, but it's something that I have introduced to a couple of groups, if you could show how much better their stuff can grow. One area that I was very happy to hear from the CRD this morning that we do similar work with Italy is in materials, in developing new Perovskite materials. So materials are the name of the game if we want to get into nuclear energy today or send things to space. So it's very important to have materials that are resistant to radiation, corrosion, and robust. So we've put together and actually just got a grant from the U.S. Naval Research Office, the international branch, because there is expertise in Armenia in making these materials, and there is expertise at this lab for irradiating those materials. So this is unique to Armenia, and unique. It's one of the few places in the world where you can make the material, irradiate it, because that irradiation causes phase changes in the material. So we found that it makes for much more radiation-hard materials that way. So the Accelerator Complex I mentioned earlier, there is proton beams from a new machine, IBA cyclotron 18 MeV, the old electron injector, and sort of the expertise put together so that we can do this. Also at the Alikhanian, we just finished commissioning a clean room. I heard CRD say level 10 or class 10. This is class 1000. And class 1000 is the first, it's the best class for Armenia to date. So this is a new clean room for the same kind of applications, the Accelerator Complex for irradiating, Academy Institute for making the materials. So joining all three aspects gave us a competitive edge, and now we can do things which are globally competitive in this area. Some pictures of the clean room. So a number of institutes within Armenia that collaborated on this and outside of Armenia. And that's the important thing for any country that wants to achieve science and technology progress. You have to show collaboration internally first. The World Bank has established that quite well. That's been difficult for former Soviet countries because the tendency was always to work out, reach out and make connections out. So the internal connections have just been pretty much enabled by me and COVID during this period. Okay. On the isotope production, it is mainly being done with the 18 MeV cyclotron, although the injector is also used to make molybdenum 100. These are the spectrometers. So this PET machine is the only one in Armenia at the moment. So that was, the game changer was to have the cyclotron producing isotopes so that you could do PET imaging. Armenia is, has the highest numbers of morbidities from cancer per capita. It's probably because of the lack of early detection, which is now enabled because the cyclotron is working and producing isotopes. Armenia has a number of grants from IAEA to produce new isotopes, particularly for gallium-68, which is important for prostate cancer. So there is some effort to try and expand the tool chest for the isotopes that are available. People in Armenia still smoke a lot. So developing something that you can test for lung cancer will be very important, like maybe gases of krypton. I mentioned the Pharmaceutical Institute that could double or triple its market share if they would do some testing that way. And we are working with the UNESCO Institute in Yerevan, as well as the Academy Institute on Biochemistry, to do these tests on animals with PET isotopes. Okay. We're far away from developing theranostics, so other isotopes that can go in with the diagnostics and treatment aspect, but that's something in our horizon. In May 3, the government of Armenia, I don't know why this is going, I must be pressing it too hard. The government of Armenia signed an MOU with the State Department of the United States on collaborating on small modular reactors. And I have put together a team to try and do some research on small modular nuclear reactors in Armenia. Our collaborators are listed here. The idea is to work on a conceptual design and work towards a prototype, perhaps. This is from the Idaho National Laboratories USA plan. We just heard it last week in Washington, D.C. at the Working Group 9 meeting. But there is a robust effort in the U.S. to go with modular detectors. There has been a robust effort in Europe to go with modular detectors. So we've been thinking about, what's different. So our efforts will be focused on fast modular reactors. The other idea is that Armenia has a small IT community. We were trying to bring the community into the Physics Institute to be a part of the National Science Laboratory. This has been seen and recommended by lots of people who know about business, and we've done this already. We have 3 IT companies. Typically, the CEOs of IT companies in Armenia were physicists by training, so bringing them to the Institute will both make us more competitive for physics grants and will also help the companies get better algorithms and work more quickly. The other aspect that we're working on is that to modernize the production capabilities of the Institute. This Institute has performed miracles in terms of building equipment that is outstanding, outperforming on the international level, but usually just one. They make one. This idea of going to a production line doesn't exist. Making a production plant doesn't exist. So I've been trying to work on getting patents for equipment that are produced and trying to see if we could modernize the production capabilities. The patent law in Armenia was extremely weak, but now there has been improvement just this year so that it actually holds some water and can protect industries. This solar panel here employs a technology where you're not using silicon for the solar cell, you're using rare earth, and the top lens is a focusing aspect, and the person who owns this technology has a company in the United States and has been willing to help us modernize the production laboratory, but it's all in design and not yet real. During COVID, the young scientists and engineers in the lab made a number of things that were, I thought, pretty amazing. And I wanted to get patents out, but they weren't willing to go that far because it takes discipline to do patents. So, for example, the mask that I was wearing, or it's in my pocket, I guess, is a mask that has silver and copper nanoparticles in an inner layer. I tested this with live viruses and bacteria, kills them. So it's a really nice protective mask made of cloth, but you can also wash it and reuse it up to 30 times. The nanoparticles stay fixed. And we also built by hand some ozone generators that could sterilize a 40 square meter room in 1 hour. And we donated these to the local hospitals at the beginning of the pandemic when they had large groups of people in quarantine in different areas. It was a way to get all the young people to come to the lab and start working instead of staying home when everybody was in isolation. I'll mention one last thing, I'm probably running out of time, that this concept of a national science laboratory wanted to expand to include the innovation park. So we wrote a proposal to the World Bank to convert it into an innovation center. We thought we had all the components. We had the scientists, we had the know-how, we had the engineers, we had the ideas. Can we make this into an innovation hub? The proposal was received very seriously and is in progress. I'll mention one other thing here, these Armenian Society of Fellows. This is a new organization from, includes all the countries in the world. It's an academic organization. We're doing the launch from Venice next week, next Monday. Venice has been a center of learning for Armenians. The island of San Lazzaro has been home to priests since the 12th century, I believe. And we thought this was the right place to launch such an organization. It's academics from all over the world to try and help. When I said science, innovation, and sustainability are challenges for Armenia, not just challenges, really survival. And the war in 2020 really shook the entire globe for us. And it's an existential moment for Armenia. Okay, just something on the new possibilities which haven't yet been developed with the cyclotron is to try and study objects of cultural heritage in Armenia. At the moment, Armenian old objects are sent to Italy for analysis and to France. And I'm starting to do some classes on how you can do this. We do it at the Nuclear Science Laboratory at Notre Dame. So this is a map of Yerevan, where I propose to have this World Bank Technology and Innovation Corridor. The laboratory itself has different campuses. The place near Yerevan is beautiful by the gorge of the river Rastan. There are 2 stations on Mount Arakat at the very peak and also at 2,000 meters. And there is an underground salt mine right in the city where research is done. Those are the campuses. This is the proposal to the World Bank, is to try and build 3 institutes within this National Science Laboratory. The World Bank team was visiting Armenia last week. I gave them a presentation on Friday, and they're quite serious about doing this in Armenia. I invited an architect from Harvard University in the United States to help us design the campus. The campus, the Russians did not think about sustainability. They built things. The idea was never to keep it sustained. So the campus is quite old. Buildings are old. They haven't been maintained. So the idea, but people of Armenia are very attached to the scientific history of having created an electron accelerator. I believe there was a competition with Novosibirsk. Armenians got to make theirs work when Novosibirsk didn't, so they're very proud of this. So the idea is to build something modern on top of the old buildings. So both maintaining the scientific history and also making a modern lab on top. So these are some ideas, some visuals, and the most valuable resource, like in every country, are the young people. And we have, through the news of the accomplishments at this Ali Khanian National Science Laboratory, we have a lot of enthusiasm from young people. The astounding thing to me is that last year when we had conferences, we had 83 volunteers come to help us run the conferences. They were students in the medical school, they were students at the law school, they were not even scientists, but they wanted to come and be a part of meeting the scientists that were coming to Armenia. They wanted to be a part of what we're doing at Ali Khanian. And I have had lots of people ask me if they could come to do internships in the summer to Armenia, and until recently I was saying no. But last year we had 11 interns from the United States come to do research, and they all want to come back. Anyhow, that's all I had to say about are we going to survive this innovation atmosphere? Are we going to be able to sustain? Are we going to survive in the way that I think is necessary by becoming a science and technology country? I hope so, but I don't know for sure. But I will end my talk by inviting you all to come to Starmus in Yerevan. It's September 5 to 10. Starmus is a big global gathering of scientists, musicians, artists. I was last told there were 20 Nobel Prize winners coming. I've contacted various people in Europe and the American Physical Society. There's a lot of interest. They have a theme usually. This is Starmus 6, and it's the theme is 50 years on Mars. It turns out that the Mars rover and even the rover on the moon was discovered by an Armenian engineer, or made, not discovered. So thank you for your attention. I'm happy to take questions.
Thank you, Annie, for this, I think, very involving talk. I think you are a fantastic testimonial for Armenia, really. There are questions, please.
Yeah, I concur to what you just said. Impressive, Annie. I mean, for short time, you implemented so many things. Wow, I'm impressed. Thank you. Maybe one comment. From my point of view, I see that the project of nuclear medicine and the project of nuclear energy, the small modular reactor, maybe are the most sustainable project for Armenia. And maybe the question is, to what extent do you think not only your implementation, but the boost, these ideas will be followed and finally will have both the nuclear medicine, I mean the radioisotope production, and the small reactor to be completed. Any timeline for these, and how you will ensure that things will happen after your time? Hopefully you will stay anyway.
Thank you, Faisal. The nuclear medicine part, there is huge commitment for, and it's happening already. So the fluorine-18 is actually going out. So now medical centers are buying other PET machines, and it's really, it will be sustainable in the long term. The modular nuclear reactors, that's just starting new, and I really pushed for it last year to develop the group and collect all the expertise. It's usually, Armenia has this one power plant, it's very old. In the past, it had two. One of them was shut down after independence. This one is renovated. This one produces 30% of the electricity of Armenia. So when I talk about the modular reactors, I wasn't thinking for electricity for Armenia, but as being able to get to market modular nuclear reactors. The location of Armenia is a geopolitical center, and with climate change, I hope it is sustainable, but I don't know. But I think nuclear medicine will be, for sure.
Yeah, thank you very much. That was really great. I just had a comment. You talked about the young people, and I have to concur because at ICDP we worked with, actually we got an application for a conference in Armenia that was put forward by students. And they invited Sir Michael Berry and a bunch of other people, and we funded it, but it was really amazing. The students in Armenia, as you said, are extremely active. Also in the EPS Young Minds, there's a young woman there, and she started a Young Minds chapter. Absolutely, I think she went to the board, but she's absolutely very productive. So at any rate, compliments on all the young people. They're really doing a great job.
Thank you.
Look, just to follow up, so thank you very much for the great talk. And I'm sure that if every physicist is like you and in Armenia, I'm pretty sure that Armenia will survive. I have no doubt about that, okay? Yes, we are,
from your mouth to God's ears.
for sure, yeah. So as Joe mentioned, I mean, we have two local sections in the EPS funded by the Young Minds, by the EPS Young Minds, one in Artsakh and the other one in Yerevan. And I can testimony that indeed, I mean, the young physicists here, I mean, they are incredible, very enthusiastic, like you. So.
Not so young.
No, but you look in any case. And I wanted to ask you for this Ali Khanian laboratory in Yerevan. So it's located in Yerevan.
Yes.
So you mentioned, I mean, the many cooperations with Notre Dame or CERN and so on. What about the internal collaborations with inside Armenia? Have you any cooperation with other university centers in Armenia?
With the university. So, for example, Yerevan State University is the most research active. The Russian Armenian University is working in materials. The Polytechnic University is working in nuclear energy. So what I've tried to do is collect people with their different expertise for the different projects. This international grant on materials included two National Academy Science Institutes, the Physical Chemistry Institute. So within Armenia, that's been my effort within Armenia to make these groups come together. And the testing on the medical isotopes is being done by also two institutes within Yerevan.
Within Yerevan,
yeah.
But outside Yerevan, you have other locations?
Outside Yerevan, there really isn't very much. The cities are like Dilijan and Gymri.
Artsakh, no, there's...
Artsakh.
Maybe.
We've
Maybe
been the Young Minds,
Yeah.
young woman that both Joe and you were referring to, she's made a lot of efforts for teaching in Artsakh.
Okay.
We're collaborating with Artsakh University.
Okay. Thank you.
We're not forgetting them.
Thank you. Yes. Rosario.
Also, thanks for your talk. A question is concerning why you have such enthusiasm for scientists, science and STEM material and STEM subjects in Armenia. Do you have a program which goes also to very young students or is coming out from, I don't know, the social situation? Because in Europe, in Italy in specific, we are trying to push our outreach work down in age, from the high school, which was rather natural in the past years, now going to the primary schools and so on. Do you have a similar things in Armenia, or it just comes from cultural heritage? What is this part of the outreach going even for the younger students, I think?
Thank you for your question. There are two parts into the answer for that. One is that during Soviet times, the scientists were heroes. So the whole country has had respect for scientists, but that had gone down. And right now, this enthusiasm that I'm talking about is coming from young people realizing that this needs to be done, but the education is not as good as it was before. So yes, we have built a hands-on museum, which is funded by funds from diaspora and the Central Bank of Armenia. So we have open houses to the laboratory every year. So young people come. The Minister of Science was actually busing in people from all the villages and Artsakh. We even put them up and they get to do hands-on experiments. So we're doing it at all levels. There is also something called Aribus, which means come to me. And it's a bus with experiments in biology, chemistry, and physics that travels around all of Armenia. So the university level entrance is hugely down. And what's happened is that this Soviet structure of being superior to the kids is what has caused damage. The kids now see the world. And then now they're excited because I don't have that attitude, and I don't let people at Ali Khanyan have that attitude. I have never talked down to any of my students, and young people, they know when something exciting is happening. I found that in my 33 years of experience at Notre Dame. Whenever we had a new project, they came before we advertised. So I think we have to show the excitement about what we're doing. When we do exciting things, they come. And yes, we are pushing the outreach all the way down to the very first years of school.
We have to end the session, but I would like to thank you again, Annie, for your talk. I think your presentation will remain in our minds and our hearts also. Thank you. So we reconvene at 2:30, right? Okay.